Hey everyone, back again with another video, and this video can be considered like the final part. Well, not necessarily the final, because I may still make a video about this later, but it's the video where we'll actually be sending the video stream over the network, which would actually like complete my goal for this. So yeah. So first thing we're gonna fix a couple things. So there's like my misunderstanding of what the TCP protocol meant, because I thought that because we were using TCP and this sort stream thing here, kind of it it by default it will give us a TCP socket, but we also have to specify it here. But this is not the misunderstanding I was talking about. The misunderstanding is actually that I thought that when we use TCP, that when we use the RecV thing here, that it would block the thread until all the data was received, but turns out that isn't the case. You actually have to keep this in the while loop until all data is received. So if you're sending anything with a decent size, it may not actually receive all of it in this one call here to it. So yeah, we have to do that. We have to fix that for sure. That is a major issue. But other than that, everything else went as planned. So let's just get started. So first thing first, what I want to do is just make some things right. They'll use the latest version of the DLL, the WSAF library. So the latest version that I know of is actually 2.2. So just change that in both the server and the network.h file, network CPP. So there's network.init and network constructor. So both of these here. Next, next thing we want to do is actually make the change that I just talked about. The TCP thing. Let's just do that. And the third parameter of this thing right here, the socket function, we're gonna pass something called IP proto TCP. Okay. By passing 0, it pretty much already by default creates a TCP socket because we specify source string here, but we're just gonna explicitly state it. So the same thing here, IP proto TCP. Okay, and that's fine. Next thing we want to do is, well, be sure to do these same things on the server too. Well, I'm gonna head over to the server after I'm done here. So what we want to do now is actually fix the thing I talked about earlier as well, with checking where we have to we have to make sure the amount of data we receive is actually what we're expecting, so data size. So just do this for every single function where you're using RecV. So declare a variable called int. You can call it check. I call it check. And then we can create a do while loop. This is pretty much one of the only templates I've ever found to use for a do while loop. So what you want to do is actually use RecV in here and assign the return value to check. And while check is less than the data size, which is what we are expecting, how much data we are expecting to receive, then we just want to keep doing it. So yeah, that works out pretty good. And what we want to do is in here, because if this returns a socket error, then a socket error I believe is -1, so we will literally never get out of the while loop. So what we need to do is place this if statement inside of the actual dual. Okay, and that should be fine from there. So do that for literally everything else. The only thing that would change really is instead of world check less than data size, they might have to use something like size of int. Actually, in this specific one, we actually just want we actually just wanted to make sure check is less than the size of an int, because that's what we're receiving. So yeah, you could basically do the same thing for everything else using RAV. Only thing else we'll be using data size in the other ones, and in the case of this in the case of the message type, you'll be using message type. What I was going to do is I was actually going to just skip edit out most of that because it would have been straightforward, but I'm just going to do all of it here. So here we're using RecV. So let's just make an int called check. Oh yeah, and we are supposed to use plus equal, not just equal, because it's just adding on to what we get. So yeah, plus equal, and let's do it here. Do and let's just do the thing check plus equal this thing here, RecV. Okay, and let's just copy the S statement from here and put it inside the actual dual. Okay, and f check equals second error. Okay, that's fine. Now let's just set up the world logic. So a world check is less than data size in this case, because this is the amount of data we're receiving. Yeah. And the same thing can be done for the getFrame and getCameraFrame. So yeah, just declare it in chat. And you can default it to 0 as well, so just default to 0. So that's what I should go and do in all of these cases. Okay, and I'll edit from here and let you guys finish. And this one here, yeah, you just, instead of passing data size, you're just gonna pass size of message type. So let me show you what I mean. So we already are doing it outside, so we could just do a do statement and declare the check thing outside. So declare to 0. Move this up, and then okay, instead just do this check inside of the do statement as usual. The only thing that will change for our get message type function is the while loop, the while logic, which will be f check is less than the size of message type, the actual struct. Or you could even use the variable name itself and the size of function, but doesn't really matter. So just gonna use size of message type, and yeah, we should define from there. This the while statement end with a semicolon at the end here, so don't forget that. Okay, so that looks pretty good for get frame resolution. Same kind of thing, but we'll be using size of resolution instead. So follow the same basic pattern, and be sure to initialize this thing to 0, because when initializing the integer, it could be anything. It could come out to be anything really. And since we're using plus equal right here, since we're using plus equal, don't forget to do that. Sorry about that, kind of sloppy, but yeah, we're supposed to be using plus equal, which means that if this initializes to be some random number, we'll just be adding on to it, not assigning to it. So that could be a problem if we don't initialize to 0. So make a do statement here. Okay, and let's move the f statement up into there. Okay, and make sure to do the while logic too. While check is less than size of resolution. And we don't have to do anything with these send thing, the things we're sending. So all of these are fine. Or maybe we do. I'm not too sure, but it works without this. So it works without making the same chat for our sending. So I'm gonna just assume that we don't have to. But we are, when I test it, I do get some artifacts in the image sometimes. That may be way too. So I'll make a test with it where I check the size of the thing we're sending to. But for now, this is fine. So yeah, everywhere we are using RecV inside of here, we are now checking the annual loop. So that's good. And do the same for network. Literally the same thing. I'm just gonna assume that you can get do without me thing. Do the same thing in the main and the server, or the main file of the server. So as you can see here, the get in has this check using. So yeah, everything is pretty much the same, especially since they have the same function name. Don't worry about if there are any differences in between where we left this off or anything. Anything I changed probably isn't too important. It won't break anything. So yeah. So next thing we want to do, after we fix that, there's a memory leak in here somewhere. Actually, I won't say where it is yet. But yeah. Next thing we want to do is I decided instead of converting the image to RGB first and then sending it, we're actually going to send the compressed data over the network. That is best for the network since we always want to send as least data as possible. So that's why I decided to do that. So yeah, let's just get started with that. Okay, so here what we'll be doing is, instead of, remember, this is a callback from the camera when we receive a frame. So what we'll be doing is, instead of doing this stuff right here, inside right here, what we'll actually be doing is we'll move this into the receive frame from the network. Okay, so move pretty much everything out of here. And we don't want to send the thing anymore, so we could move this as well. In fact, yeah, that will be moved here as well. In fact, no, as I said, we were going to be sending the compressed data, so actually this is something you guys need to add, not something that needs to be removed. So yeah, this is something you guys need to add. So just send the camera frame. Okay. And I think I have to add the camera frame thing. I don't think I added that with you guys. So send camera frame is pretty much the same thing. If we go to network.cpp, get camera frame is pretty much the same thing as get frame. Like literally that same thing. So no difference there. But the sending one, send camera frame, the only thing it does different is it doesn't assume the size will just be 4 times the resolution, the width by the height. It actually uses the actual data size. So as you can see, it actually sends the data size. It doesn't assume that data size will be 4 times the resolution width by height. It actually takes in a unsigned int here, and whereas the normal send frame doesn't. We could have probably modified the normal send frame to do this, but I just decided that I wanted to create a separate function. You guys could just extend the normal one to do that if you want to. But okay, moving on. As you can see, it does mostly the same thing, but just only difference is this thing here and right here. What we'll do, the only thing we'll do inside here, we won't even use this clock thing anymore. So let me first just paste the thing I have copied in the buffer. So instead of using CUD, we are just going to use frame because we have it available in the global scope. We aren't going to use CUD anymore. We just have to use the receive resolution. Receive res dot, and it's a reference, so we don't have to use the arrow dot width. Receive res dot height multiplied by 4, so that is how that changes. And then of course we aren't going to be using LP videos, LP vid. Just use the receive frame, and then here we are just going to use the frame that's available in the global scope. Okay, and then this logic here, we're just going to do, as you can see, we're taking in data size here. I think I'm taking that in the normal thing, but either way, here in network.cpp, if I am not doing it from last video, just inside of getCameraFrame. Inside of getCameraFrame, just pass data size right here, if that is not the case. Yeah. So here we're now gonna, instead of using this lpvid dot down, we're gonna use data size. Okay. And from there we should be pretty much set. So now after that we just want to do completed true, which we are doing, and then we're gonna end the clock. Oh yeah, and we need to copy these two things from here, because you still want to, I still want to time this. So okay, that should be fine. So what we're doing in here, we're just setting the frame thing. Okay, this looks fine. So the next thing I want to do here is fix a memory leak, which you will get if you don't do this. So this receive frame thing here. So as I was saying, this receive frame, this is actually allocated memory. So remember here in network CPP where we are sending receive cam frame and stuff. And so here, what we're actually doing, we are allocating this memory. So right here, we're allocating this, and then we're just sending it on here, but we're never deleting it anywhere. And yeah, it could actually, when it was testing this, it just had a memory leak and it just went up to like 2 gigabytes of usage, then it crashed. But no, if as long as we want, what we want to do here is after we are complete, we know we don't need it anymore, just delete it, delete receive frame. Let's just make it the last thing we do. Okay, and that should be fine from there. It should fix the memory leak. Okay, we should be good. Next thing we want to do is just, actually I don't think there's anything else you need to do. So the memory leak is no fix, and what I could do is open up the task manager and I could show you guys that it doesn't leak. So what I'm going to do, be sure to compile everything, so just activate this and compile this. I'm just going to rebuild everything. So what is it saying now? Oh, the semicolon, I left the semicolon here, I believe. This thing here just something I had for testing. And this also, this is just something I have for testing, don't worry. And you can totally ignore these things here about these comparing unsigned into assigned integer. So yeah, okay, that's working fine. So also get a server, activate a server, and just compile it. I'm just going to rebuild just to be safe, but yeah, as you can see, it's all fine here. So what I'm going to do, I'm actually going to open up 3 instances of this project, and this is actually in the release build. I didn't realize, so we have to go in the release folder. So here in the bin folder inside release, remember, because I compiled for release. If you were compiling for debug, then just go inside debug. And then I'm going to open up three instances of this. The first one here I'm going to use as the actual thing that's sending the camera thing. And I'm going to open up two other ones. This one here, let's just make this smaller to accommodate for another one. And lastly, another one. So what I'm going to do, guys, I'm just going to click on, let's just move this. I'm going to click on this one here, and then I'm going to press space, and let's see what happens. Sometimes you have to press more than once. And then when I find sometimes I actually have to click on the console thing, not the actual window. So right as you can see, I have to click on the console. Not too sure what's going on there. Okay, guys, one other thing I wanted to do. Here where we're using. I already changed it, but as you can see, the last time we did this, I think I told you guys to use capture sequence. So just use no fill thing here. Just add on this no fill because we don't want to fill. Alright guys, so I see the issue. The issue is that I forgot to assign the resolution. So right here above frame, just do this here. Do res. This is the res in the global scope, by the way. Just do res equals receive res. If you plan on moving this into a different file, I don't plan on moving the receive frame callback, which is the one from the network, to a different file. So I just use the global variables one time, but if you do plan on moving this, then you could probably set it as a parameter here. But yeah, this will be available as long as you have any main info. Okay, and after that you'll see it will work now. So let's just be sure to compile. So activate skull and then compile. Okay, so that worked. So let's just now activate the server, run one instance of the server. And then here in the release one, because I'm using release, if you guys compile it in debug, be sure to use debug, please. And then I'm gonna open one instance. This one is the one that's gonna send the camera footage, the camera video. So I'm just gonna make this tiny. Okay, and the other ones, let's just also move this. The other ones are the one that's gonna be receiving the frame. So let's just take this up in the top right corner and make it smaller. And let's do that with the other one. Create another one, and I'm gonna send it to two instances to let you guys see that does work. Yeah. And what I'm gonna do is just gonna go here and press space and press space. Actually, I think you actually have to press on the console first and then press space. So as you can see, it's not working. So yeah, this is it. As you can see, it's actually working. And as you can see, one of them is actually sometimes you get an artifact like the green thing. I think that I don't know if it's because I'm deleting the frame. But as you can see, I don't know if it's because I'm deleting the frame before it gets to use it or something like that. Actually, I'm just deleting the receive frame, not the actual frame in the global scope. The frame in the global scope I actually delete after we set it as a texture, so that shouldn't be a problem. So yeah, as you guys can see, it's actually working fine. Okay, and if we look at the task manager, you can see, hopefully you'll be able to see, they have quite high CPU usage, but the memory usage never goes past this 20 megabyte mark, like 21 megabytes or 22. But as you can see, the CPU usage is quite high, and as I said, there's a lot of things you can do to, well, there's three main things I can think about to optimize this. First thing first, what we do, as I said earlier in the network, in the OpenGL functions, the update texture thing, we should probably make this so that it doesn't have to allocate a new thing every time. So we should be using here if I can find the so yeah, we should be using GL text sub image 2D. Let me show you what that looks like. So yeah, we should be using this instead of the normal 2D one, but I'm gonna leave that up to you to do that if you want to. So just gonna do some research on it. And next thing we can do, since we know it's going to be the same size, since we know the stream coming from the camera is going to be the same size, we don't have to reallocate a buffer everything, which I assume is where most of the memory usage, most of the CPU usage is coming from. Because think about it, you have to delete a frame and allocate a new frame every single frame. That's like 60 times, 30 times a second if this resolution, if the frame rate is actually running as I said. So yeah, those are the two main things I can think about that will speed this up greatly. As long as the resolution is the same, we could just, instead of assigning this all the time, we could just assign this one time in some place, not somewhere else, not here. And yeah, I think that would help the CPU usage of this program a lot. And I mean, also, if you guys actually do plan on making this into like actual little application that you want to use, then what you would need to do from here is actually create something to manage connections and clients for the server. So as you can see, the server logic is pretty basic. It literally just accepts up to 5 connections, and even if someone disconnects after they connect, then it won't recognize that. So it will just add those 5 connections, and after that, it will just not stop accepting connections, even if someone disconnects, which would theoretically open one place for someone to connect. So, if you actually want to do something serious with this, then actually just you can actually just like create something to manage the clients and threads properly. And then next thing, to deploy this on a server, as you can see here, we're listening to localhost. This is the binding address, so this will only listen to things from localhost. What we want to do is change this. Remember, we declared something here called anyhost. So right here, localhost and anyhost. So what we want to do is listen to things from. What this anyhost thing here does is this listens to connections from anywhere, which could possibly be remote, like just connecting to a server. So here in the main function, let's just change this to anyhost. Okay, and let me just close the currently running programs. Interestingly, what you'll see, let's compare the server and run. And what you'll see now is when we try to run this, we actually have to get, usually when you connect to any host, you actually have to get permission. Let's do a rebuild of this. I think it already granted it permission. Yeah, it probably already granted it permission to do what it wants to do, but usually it would bring up a prompt asking you to give permission to run on private networks and public networks and that kind of stuff. And also, guys, next thing, probably next logical step for this will be to include audio. I don't see it as something being hard to include, but it's just that I literally have no idea how audio works right now. Like how is it stored in memory? Like what do we like? How does it actually play and stuff? Like that's something we'll have to go and research a little. I would probably catch on pretty fast, but yeah, it just I'm not super interested in audio. That's the honest truth. Like that's why, like to me, getting the sending the image over is like the most important part. But I guess audio is important too. So yeah, I might do that. So look out for something like that. I might do that. And as you can see, we could actually turn this into like a streaming service where we could actually even stream MP4 files or something, as long as we have a library to open those kind of files. Because of course, I'm not gonna try to make a library myself to open those files. So yeah, this could actually be turned out to be something pretty good, like something like Plex. Of course, it's not gonna be as like nearly as fleshed out as something like Plex or something, but yeah, we could stream our own thing. We will have our own streaming server, and yeah. But yeah, that's it. So see you guys in the next one.